All right, let's see here. Welcome to the Crazy Hat Chemist. So here is our second video in nomenclature worksheet number 1. And last time we ended from doing formulas to names. And today, the second half, what we're going to be doing is going from the name to the formula. And excuse me. What I'm going to remind you of is the following. You do need to know your periodic trends, and here are our periodic trends. The alkaline metals, the alkaline earth metals, that's group 1, group 2, that's 1 plus, 2 plus, 3 plus, 4 plus, 5 plus, and then we're going to count 5. 1, 2, 3, 4, 5, and of those 5, they are all 2s and 3s. And then we are going too fast at a speed of 2s and 3s. So that's why we hit copper slows us down, and we're going to decrease our speed by 1 of each of those. -1 from there, -1 from there. That's why copper is a 1 and a 2 plus. We have silver, zinc, aluminum, and cadmium is in this diagonal pattern and a line down. That's a single charge of 1 plus, 2 plus, and 3 plus, and cadmium has a 2 plus. Gold is a 1 and a 3. Notice that copper, silver, and gold have a common charge, and then gold is worth more. So of course it's a 3 plus. There's mercury, there's a mercurous at a 1 plus and a mercuric at 2 plus, and both of those are right here. The mercurous has that 2 right down there, and the mercuric has a 2 plus without the 2. We have tin and lead, that's stannous and stannic. We have plumbus and plumbic. And then we have this dividing orange line that separates the metals from the nonmetals. The metals are on the left-hand side, excluding hydrogen. The nonmetals are on the right-hand side. 0 charge for the noble gases, -1 for the halide ions or halogens, -2, -3, plus or -4. And then in this column, it's mostly a +3. Let's see, what else are we going to mention? We're going to mention that our metalloids are 1, 2, 3, 4, 5, 6, 7. And our diatomics are 1, 2, 3, 4, 5, 6, and 7. Okie doke, then we'll pull this away and then put this on here. And the other thing that we need to know is our charges on our ions and their oxidation numbers. And that really encompasses what I did with periodic trend charges right there. And that includes these transition elements as well. One thing I didn't mention at the first video, and I'll mention that here, when you burn these ions in a solution, so not the element itself, but the ion, when you burn that, then you get the associated color that I have written down here. And that is really something that you probably might want to memorize. But on the flip side of this sheet of paper are not the monoatomic ions, but the polyatomic ions. And you do have to have these memorized. Ammonium ion is the only polyatomic cation. And that's the only one on this left-hand side. And then the anions, there's a whole bunch of those, and you do have to memorize those. That is most for certain. There's a lot of those. And then there are binary non-metal, then there are binary covalent compounds. And binary covalent compounds are 2 non-metals together, and that includes prefix naming here. We have acids, we have bases, we have acids, and some nomenclature for that as well. You are watching the Crazy Hat Chemist, and I hope you are having a good morning, good afternoon, and a good evening. And so we're going to get started, assuming that you know all this material. The other one thing I'm going to make an assumption on is that you have watched my video on this unit. That would be exceedingly helpful before you actually proceed on forward. All right, cool. So let's peel these things away. Let's zoom in and start doing our problems. All right, so today we're going to be going from the name to the formula. So this is pretty much the same thing, but in reverse of what we did last time. So barium is a group 2, that's a +2 charge, and hydroxide is a polyatomic ion, that is a -1 charge. So from that, I'm going to take the absolute value of these numbers right here and take the bull by the horns, flip the numbers, bring it down. I get Ba parentheses OH and a 2. All right. Fantastic. Hopefully that worked for you. Notice that this is one of the common mistakes of not having parentheses around hydroxides. when you have more than one, but you do need the parentheses when you have more than one. The next one is zinc chloride, and zinc is a periodic trend charge of 2+. Chloride is a halide ion, that's a 1-. We're going to take the absolute value of these two numbers, flip those numbers, bring them down, we get ZnCl2. All right, fantastic. And now we are on 68. So we have plumbic iodide, and plumbic is a 4+ charge. Iodide is a halide ion of -1. We're going to take the absolute value of these numbers, flip the numbers, bring it down. We get PbI4. All right. Next one is ammonium cyanide, and that is NH4 1+. That's the only polyatomic cation there is, and cyanide is a polyatomic anion. There's that charge. We're going to take the absolute value of these two, flip the numbers, bring them down. I get NH4, imaginary parentheses and a 1, CN, imaginary parentheses and a 1. Okay. All right, moving forward to number 70, we got potassium dichromate. Potassium is a group 1 chromate. Dichromate is Cr2O7 with a 2-. We're going to take the absolute value of these two numbers, flip them, bring them down, and I get K2Cr2O7. That is potassium dichromate. All right, next one is mercurous, and that is the Hg2 2+, and cyanide, Cn-1. So we're going to take the absolute value of these two numbers here and then flip the numbers, bring it down. We get Hg2, parentheses, Cn and a 2. And normally one might think, can I reduce these? You can reduce this number potentially, but this number right here always stays here because that means it's mercurous. So you cannot reduce that one. That is impossible. So make sure that that stays there just like that. The next one is manganic perchlorate, and that's manganese 3+, and then perchlorate is ClO4 1-, and you're going to take the absolute value of these two and get MnClO4 parentheses and a 3. Okay. All right, fantastic. I'm going to zoom on out here just a little bit so my hand isn't in the way as much. All right, cool. The next one here is cuprous. That's Cu1+, and then sulfate. That's SO4 2-. Absolute value of these numbers. Flip the numbers, bring them down. You get Cu2 SO4 parentheses and a 1, and then we don't write that parentheses. I'm going to slide this on up here so that we see the rest of the problems on this part of the sheet of paper here. Okie doke. Next one is ferric chloride. That's Fe3+ for ferric. Chloride is a halide ion, -1. Take the absolute value of these two numbers, flip, bring it down. I get FeCl3. Then it's cesium, Cs1+, that's group 1 hydroxide, that's polyatomic ion 1-. Take the absolute value of these two numbers right here and go CsOH, and there's parentheses, but there's the 1 outside, so we're good. We don't do anything. Cuprous, that's Cu1+, and sulfide, that's a periodic trend, that's an S and a 2-. Notice how, I'm just going to say here, we have sulfide, we have sulfate, and we have sulfite. So there's a 1-letter difference in all of those, and it's very critical that you memorize those and know those. So we're going to take the absolute value of that, so we're going to get Cu2S, and that is the formula for cuprous sulfide. All right. I'm going to get another sheet of paper here because we've got, a whole bunch more. Remember, I have 150 problems on this entire worksheet. So let's see what we can do for this next set here. And we're right here at the top, and this is zinc phosphate. So that's Zn2+, that's a periodic trend charge, and phosphate is PO4 3-. I'm going to take the absolute value of these right here, and then I get Zn3 parentheses PO4 with a 2 outside. Okay, perfect. I want to reiterate how important it is that you have your periodic trends known and your polyatomic ions known as well. You notice how fast I'm doing this? I'm doing this fast and quickly just because I have my periodic trends known. That is, I know what they are on the periodic table, or I reference my periodic table. And I most certainly have my polyatomic ions memorized. If you don't have these memorized, this nomenclature unit is pretty much impossible. So please have them memorized. And again, the fastest way to memorize your polyatomic ions is to physically actually write them out and say them out loud. It works much better, much faster, and it goes into your long-term memory. You're using all your modalities of educational modalities of memorization. Okay, say it and write it out, and you will get it. And if you do it in short blocks of time, maybe 10 to 15 minutes at most, that's it. All right, let's move on to the next one. And the next one we have Auris, and that's AU with a 1 plus, and chlorite, that's ClO2, 1 minus. Absolute value of these two numbers, flip the numbers, bring it down, so you get AuClO2. And that's Auris chloride. All right. The next one here is stannic. That's SN4 plus, and bicarbonate. That's HCO3 1 minus. So I'm going to take the absolute value of these two numbers, flip the numbers, and bring it down. That's SN parentheses HCO3 parentheses and a 4. So that's stannic bicarbonate. Next one is barium acetate. That's Ba2 plus. That's a periodic trend charge. It's group 1, and acetate CH3COO minus 1. Absolute value of these numbers, that's a Ba parentheses CH3COO parentheses and a 2, and that's barium acetate. I'm going to slide this up a little bit here. There we go. Next one is Nicholas, and that's Ni with a 2 plus, phosphate PO4 3 minus. Absolute value of these two numbers, flip the numbers, bring it down. Ni3 parentheses PO4 parentheses and a 2. Notice that you need parentheses when you have more than one of a polyatomic ion. You have more than one of a polyatomic ion, more than one of a polyatomic ion, you need the parentheses. When you don't have more than one of a polyatomic ion, you don't need the parentheses. All right. Next one is sodium bisulfate. Okay, so bisulfate. So sodium is Na1 plus, bisulfate is HSO4 1 minus. We're going to take the absolute value of these two numbers, flip the numbers, bring it down. We get NaHSO4. All right. Next one is stannous oxide. That is SN2 plus O2 minus. We're going to take the absolute value of these two numbers. We're going to get an intermediate answer. I'm going to write that down. Well, it's going to be SN2O2. But here, what we have to do is we have to reduce this. So you have to use the lowest ratio, whole number ratio. So it's SNO. All right. Next one is stannic oxalate. So that's SN4 plus. Oxalate is C2O4 2 minus. We're going to take the absolute value of these two numbers, flip them, bring them down, and we're also going to reduce this one as well. Okay. And so then we're going to get SN parentheses C2O4 parentheses and a 2. Remember, there was actually a 2 down here and a 4, and I reduced that. So that's how I got that. So SN2 C2O4 parentheses and a 4 would be my intermediate step, and then I can reduce these numbers here. You cannot reduce these numbers here that I'm circling in red because that's part of a polyatomic ion. So never reduce those numbers. The next one is aluminum iodate, Al3 plus, IO3 1 minus. And that, take the absolute value of these two numbers, bring it down, flip, bring it down, Al parentheses, IO3, parentheses, and a 3. All right, cruising on up here, and we have a zinc nitrite. So Zn, that's a periodic trend charge of nitrite, NO2, 1 minus. Again, absolute value of these numbers here, Zn, parentheses, NO2, parentheses, and a 2. Then we have calcium permanganate, that's Ca2 plus, that's a group 2. And permanganate is MnO4, 1 minus, polyatomic ion. Absolute value of these, flip the numbers, bring it down. Ca, parentheses, MnO4, parentheses, Na2. Okay, then it's mercuric hydrogen oxalate. Mercuric is Hg2 plus. Now, many people are kind of confused about this hydrogen oxalate, because it's not one of the polyatomic ions that I actually wrote down, but I do have oxalate. So oxalate is C2O4 2 minus, okay? Hydrogen oxalate is going to be sticking hydrogen associated with this. So what we're going to do is we're going to add up these two things. What do I get? I get from this, I get a hydrogen and C2O4, and now I'm going to sum up these two charges here. I got a 1 plus and a 2 minus, so summing up those charges will give me a 1 minus. That is the formula for hydrogen oxalate. In fact, you could come up with the formula for bisulfate or hydrogen sulfate in the same way. So I'm going to use this hydrogen oxalate HC2O4 1 minus here for this problem here. All right. So we're going to take the absolute value of these two numbers, flip the numbers, bring it down, Hg2, that 2, hold on just a moment. Hg, parentheses, Hc2O4, parentheses, Na2. That is it for mercuric hydrogen oxalate. All right. Then the next one is nitrogen dioxide. Notice that this has a prefix naming here. So this is going to be really easy. It's a binary nonmetal compound or binary covalent compound. So binary covalent compounds are two nonmetals. So there's nitrogen and there's oxygen. Nitrogen and oxygen. How many nitrogens? 1, because there's no prefix. How many nitrogens? 1, because there's no prefix. How many oxygens? 2, because that prefix di means 2. So this is NO2. Next one is lithium sulfide. That is Li 1 plus, and that's a periodic trend. Sulfide, that's a periodic trend. I'm going to take the absolute value of these two numbers, flip, bring it down. I get Li2S. All right, scrolling this on up here. Our next one is plumbus, Pb2 plus. Arsenate, that's ASO4 3 minus. We're going to take the absolute value of these two numbers, flip the numbers, bring them down. I get Pb3, parentheses, ASO4, parentheses, Na2. Okay. Whew. All right, so hopefully that's working for you so far. And then we're going to keep on going here. We got potassium peroxide. Potassium is a group 1. Peroxide is a polyatomic ion of O2, 2 minus. And this 2 can never be reduced. I'm going to take the absolute value of these two numbers, flip them, bring them down, and I get K2O2. And no, you cannot reduce that to KO. Not possible. Plumbic bisulfite. So plumbic is Pb4 plus, bisulfite is HSO3 1 minus. I'm going to take the absolute value of these two numbers here, Pb, flip the numbers, bring it down, HSO3 parentheses and a 4. All right, bam, looking good, baby. All right, plumbus oxide, that is Pb2 plus O2 minus. So plumbus oxide. I'm going to take the absolute value of these two numbers, flip them, bring them down. I'm going to get an intermediate step here, Pb2O2. And then what you have to do with this is actually reduce this. So these must be reduced, so you get PbO. All right, so sliding this up here a little bit here for you. Boom, 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 and here we go. Next one is phosphorus acid. So phosphorus acid, that's OUS. Does it have hydro in front of it? No, it does not. So because it does not have hydro, it's not a binary non-metal acid. So it's a polyatomic ion. Phosphorus is coming from phosphite. Phosphite is PO3, 3 minus. Acids have hydrogen ions on. So I'm going to take the absolute value of these two charged species, bring it down, I get H3PO3. And because it's a polyatomic ion acid, you don't actually need the AQ. You can add it if you want to. Next one is nitrous acid. It does not have hydro in front of it, so it's a polyatomic ion. I need to use the nitrite ion. NO2 minus 1, and all acids have hydrogen on them. So I'm going to take the absolute value of these two numbers, flip them, bring it down, I get HNO2. Then the next one here is acetic acid, and that's coming from acetate. You ate too much, you feel icky. Don't fight us. I had an icky dinner at the White House. So all that goes together. So acetate is CH3COO minus 1 and a hydrogen and a 1 plus. So you can take the absolute value of these, bring it down. And this one is an unusual one. You do need to put the hydrogen next to this oxygen, CH3COOH. And one other common mistake that you must not do is you must not add this acidic hydrogen to these hydrogens because they are most certainly different. Okay. By the way, you are watching The Crazy Hat Chemist, and this is where all your chemistry needs are met, right here. All right, cool. Let's keep on going. And so now we need to move our paper over here, and let's see, we got 98. 98 is what we're doing. Where can we find? There it is. Cesium thiosulfate. So cesium is a 1 plus charge, and then thiosulfate is S2O3 2 minus. So I'm going to take the absolute value of these two numbers here and get CS2 S2O3, and that's cesium thiosulfate. Next one is ammonium thiocyanate. That's NH41 plus. And remember, that's the only polyatomic cation there is. And SCN is thiocyanate. This is the 1-to-1 ratio. You're taking the absolute value of that. You get NH4SCN. Beautiful. Cobaltic is the higher charge for cobalt, and this is a periodic trend charge. So go back to your periodic table. That's a 3 plus. Chlorite, that's ClO2 1 minus. We're going to take the absolute value of these two numbers and get CO parentheses ClO2 and a 3 outside. Then it's stannous, that's SN2 plus, and then peroxide, that's O2 2 minus. Can I reduce that and get rid of that 2? Never. I'm going to take the absolute value of these two numbers, flip them, bring them down. I'm going to write an intermediate step, and that's SN2 O2 parentheses and 2. But these twos I can reduce. So I'm going to get SNO2. There's actually another name for this stannous peroxide, and that's stannic oxide. That could work too. If you were going backwards and actually naming that, that would work too. Next one is zinc hydrogen carbonate. That's zinc. That zinc is a 2 plus. Hydrogen and carbonate, and that is like that. I have an absolute value of these. Flip the numbers, bring them down. ZN parentheses HCO3 parentheses and a 2. All right, scrolling this on up here. Hopefully you're hanging on here. I'm trying to move fast, but yet steady so that you understand what's going on at the same time. The next one is hydrogen sulfide, and that's hydrogen 1 plus. Sulfide is a periodic trend charge like that. We're going to take the absolute value of these two numbers, and I get H2S. All right, that's a gas, and if you smell that stuff, you know you're smelling like rotten eggs. Then the next one is ferric hydroxide, that is Fe3 plus OH 1 minus. I'm going to take the absolute value of these two here. I get Fe parentheses OH and a 3 outside. The next one is a carbon trichloride. So binary nonmetal compound. So this has prefixes. So it's carbon chloride. Tri is for 3. That's a 3 right there. Okay. Chromic perchlorate, chromic is Cr with a 3 plus. Perchlorate is ClO4 1 minus. Take the absolute value of these two right over here. I get CrClO4 parentheses and a 3. Next one, rolling this down so that we got some more space here, is auric, and that's Au3 plus nitrite. That's NO2 minus 1, so that's AuNO2 parentheses and a 3. I am taking the absolute value of those two numbers, flip, bringing it down. Sulfur trioxide, sulfur oxide, tri, that's a binary covalent compound. All right, scrolling this on up here. Carbonic acid is coming from carbonate. What's carbonate? CO3 2 minus, and I'm going to add a hydrogen because it's an acid. Absolute value of these two numbers, flip the numbers, bring them down, I get H2CO3. No, you actually don't need the AQ on there. If you want to write it, go for it, it's fine. Copper 2 carbonate, Cu2 plus carbonate, CO3 2 minus. I'm going to take the absolute value of these two numbers. And this one, you're going to have a Cu2, CO3 parentheses and a 2, and then reduce that to CuCO3. Okay, hopefully that works out well for you. I didn't write that down, but I'm hoping that you can follow along with that since we've been moving pretty far along. The next one is mercuric, that's Hg2 plus cyanide CN1 minus. We're going to take the absolute value of these two numbers, flip, bring it down, and I get Hg parentheses Cn parentheses and a 2. Next one here is plumbic oxide, Pb4 plus for plumbic oxide, periodic trend, O2 2 minus. Sorry, O2 minus. Pb2O4, and then yes, you have to reduce these, and so that would be PbO2. Okay. Scrolling this on up here. Whoa, that's right, folks. All right. Calcium chromate, Ca2 plus chromate, CrO4 2 minus. Absolute value of these two numbers. Notice that this is a 1-to-1 ratio. So CaCrO4. Okay, the 2 plus and the 2 minus, they reduce down to 1s. Nitric acid is coming from nitrate. That's NO3 minus 1, an H and a 1 plus. So I get HNO3. I'm taking the absolute value of those two numbers, flip, bringing it down. Whew, here we go. 115. We are still going. We're getting closer to the 150. Let's see if we can actually make it. Cuprous, Cu1 plus, hydrogen phosphate. Okay, so what is hydrogen phosphate? Hydrogen phosphate is HPO4 and a 2 minus. We take the absolute value of these two numbers, flip, bring it down, and we get Cu2HPO4, and there's our answer. Ammonia is not ammonium ion. This is NH3, and this will be probably on your test because it's such an important compound. Okay, and it goes by a common name. It is not nitrogen trihydride. It goes by a common name, just ammonia. Perchloric acid is coming from perchlorate, and that is ClO4 1 minus. All acids have that hydrogen, so absolute value of these two numbers, flip them, bring them down, HClO4. Then we have ferric permanganate, that's Fe3 plus permanganate, MnO4 1 minus. take the absolute value of these two numbers, flip, bring it down, I get Fe parentheses MnO4 parentheses and a 3. And that is number 118. I'm thinking that we're going to keep on moving, aren't we? Yeah, I think so. Okay, so we're going to move this right here off to the side here, and then slide down this sheet of paper here. We're getting closer to that 150. I can feel it coming around the corner here pretty soon here. So hold on. You can do it. Bromine. That is a name of an element that's on the periodic table, but is one of the diatomics. So that's Br2. So sodium arsenate. Sodium is Na1 plus, arsenate is ASO4 3 minus. I'm going to take the absolute value of these two numbers, flip, bring it down. I get Na3 ASO4. Stannic chloride, that's SN4 plus Cl1 minus. I'm going to take the absolute value of these charged species, then SnCl4. Flip the numbers, bring it down. Dicarbon trisulfide. So carbon sulfide, dicarbon trisulfide. That's simple for those binary covalent compounds. That's not put together in a charge ratio of any kind. Aluminum is an Al3 plus, oxide is A2 minus. Take the absolute value of those, flip, bring it down, Al2O3. Chlorine is another name of an element that's diatomic. So you got Cl2. Perfect. And then we have benzoic acid. And so benzoic acid is coming from the benzoate ion. And that is, so acid, 1 plus for that hydrogen, and C6H5COO minus 1. So I'm going to take the absolute value of these two numbers here, flip, bring them down, and I get C6H5COOH. And this is very similar to acetic acid. We do not add it to these 5 hydrogens, and we add it next to the oxygen. That's how that runs. Phosphorus is coming from phosphite. Phosphite is PO3 3 minus, and it's an acid, so I'm going to have a hydrogen there. I'm going to take the absolute value of these numbers, flip, bring it down, H3PO3. Okay, here we go. Hypochlorous acid. So that is coming from the hypochlorite ion, and that is right there. ClO1 minus, it's an acid, it has hydrogen. I'm going to take the absolute value of this number 1 and that number 1, and I get HClO, just like that. Chloric acid is coming from the chlorate ion, and that's ClO3 1 minus, hydrogen because it's an acid. So flip the numbers, bring it down, HClO3. Okay, perfect. Scrolling on up so we get some more done. Ammonium hydroxide, that's NH4 1 plus hydroxide OH1 minus. Those are 2 polyatomic ions. That's NH4OH. I'm going to take those numbers, flip, bring them down. Dinitrogen pentoxide, nitrogen oxide, nitrogen oxide. How many nitrogens? Di, that's 2. How many oxygens? Penta, that's 5. Okay, gotta know those. All right, so it looks like we're going to mix it up here for our last sets of problems here. We got some names and some formulas kind of mixed up in here, so adding a little bit more to the mix here. All right, so we've got 131, and so what we're going to do is we're going to take that number, flip, and bring it up, and the parentheses around that 1, and flip and bring it up. So this is cuprous, or copper, Roman numeral 1, and this is silicate. That polyatomic ion, SiO3 with a 2, that's silicate. All right. Next one, we're going to take this 2, bring it up. That's the charge on the carbonate. This 3, bring it up, and that's the charge on the iron. So it's iron, Roman numeral 3, or ferric, and then carbonate. All right. The next one is we're going to bring this 2 up. We're going to bring this 1 up. And it just so happens that this is tetraborate, and tetraborate is actually a 2 charge, and then that it makes this a 4 since we need to maintain the ratio. So this is stannic tetraborate. All right, we're really pushing the limits here. So scrolling this up here. I didn't have platinum of any kind on there, but you should be able to figure out the charge on the platinum. It's right there. Platinum, and then the charge is Roman numeral 4, and then it's hydroxide. So hopefully that's not too bad. And then this is zinc, and then cyanide. And that's based on that polyatomic ion. Really simple. This is antimony, Roman numeral 5, okay? The charge on that antimony is a 5, and this S2O3, we worked with that earlier here, and that is thiosulfate. All right. Then this next one is nickel, Roman numeral 3. Roman numeral 3, or nickelic hydroxide. Nickelic. And then this next one right here, let's scroll this on up so you can actually see that. Okay, bingo. This next one has nitrogen and oxygen in it. Okay, so how many nitrogens? 3. The prefix for that is tri. So tri nitrogen, and then 6 oxygens. So 6 is hex. Hexa, and I'm going to get rid of the A on the hexa, and then it's oxide. So trinitrogen hexoxide. Okay, all right, that's not too bad, I'm thinking. All right, and this is silver, and that's borate. There's the charge on the borate. So silver, borate. By the way, I am the crazy hat chemist. You are watching me, and you're going to hang on. We've got like 10 more problems yet to do, and I think we can do this right now. I think we can hammer this out. Let's do it. Let's do it. Come on. All right, this is bismuth, Roman numeral 3, oxalate. Roman numeral 3, oxalate. So like it's none of your bismuth. Okay, phosphorus, so phosphorus and oxide, but how many phosphorus? Pentaphosphorus. And then heptoxide. Right? Hepta is for 7. Oxalic acid, that's coming from the oxalate ion, which is C2O42 minus. So I'm going to add the appropriate number of hydrogens, take the bull by the horn, flip, bring it down. I got H2C2O4, and no, you cannot reduce those because these two, that 2 and that 4 cannot be reduced whatsoever. All right. The next one is manganese. That's Mn2 plus arsenate, ASO43 minus. That's Mn. Can take the bull by the horn, flip, bring it down to those absolute values. Mn3, ASO4, and a 2. Cobaltus, CO2 plus, and then bisulfate, HSO4, 1 minus. Take the absolute value of those, flip, bring it down, you got CO, HSO4, and a 2. Mercurous, that's Hg2, 2 plus, dichromate, Cr2O7, 2 minus, and those 2's right here disappear because they are a 1-to-1 ratio. So you should get Hg2, Cr2O7. Yes, folks, we've got 5 more. I think we can do it. Boric acid is coming from borate, and borate is BO33 minus, and that's an H on that for acids. So that's H3BO3, and that is boric acid. octa nitrogen oxide. So nitrogen oxide. Octa is 8, and then deca is 10. So there we go. Simple as that. Sodium is a 1 plus. Ferrocyanide is Fe. Cn parentheses 6, and then the little brackets and a 3. So that one's a tough one. So it's going to be Na3 brackets Fe parentheses Cn parentheses 6 parentheses brackets. That's a crazy one. Oh yeah. You can do it though. Cadmium CaCd 2 plus. Iodite is IO2 1 minus. I know my class is super excited about this. Okay, we're going to take the bull by the horn, flip, bring it down. We get CdIO2 with a 2 outside. And then our very, very last one here, folks. I know you're hanging on. Good job. Au3 plus peroxide, O2 2 minus. Take the absolute value of these two, flip the numbers, bring it down, and you get Au2, parentheses, O2, and A3. That's a complicated one. That's auric peroxide. You've got it. Nailed down. Remember to memorize your ions, memorize your polyatomic ions, know your periodic trends, and like and subscribe. Give me some comments. I love y'all, and I want you to become knowledgeable in chemistry. We will talk later, and thank you very much. Bye for now.